This is project number 2, video 3, the documentation and final touches. I guess I'm concerned that I'll forget to fix up the plot. That's a big part of it, but I don't have to do that every single one. I'm going to do the checklist as a mental checklist, but one of the things I know that comes up and whenever there's a graph is you have to title the graph and title the axis. So I'll title the graph the voltage across R2, R sub 2. I'm going to try that with a cap. Versus R sub 3. I'm going to put a single quote, end parentheses, and I'll put a semicolon. I think that's going to work. Voltage across R2 versus the value of R3. I think I'll put a value of, and then we'll see if it's too wordy for the title. See if it takes up too much space. And then X label R sub 3 space units of ohms, and then close the quote. Okay. Y label voltage across R2. I think I'll just call it V underscore for subscript 2, and volts are the units in square brackets. Let's see what that looks like. Save it. I'm going to try running it. Zoom it down so you can see it. And I'll resize it so you can see it. Voltage across R2 versus value of R3. That looks good. V sub 2 in volts versus R sub 3 in ohms. I'm going to try putting a little bit more space there so it doesn't, makes it more obvious that it's the units. R3 in ohms, V2 in volts, V2 versus R3, voltage across R2 versus value of R3. I think we're good. Alright, now I'm going to go through the mental checklist. I've got to say, write comments saying what this function does. Plot V2 makes a graph of the voltage across R2 versus the value of R3 for the case of a circuit consisting of a seed of EMF in series with resistor of resistance R1 in series with a parallel combination of a resistor with resistance R2 and a resistor with resistance R3 as a function of the value. I think I already said that part. You have to clearly and completely say what the function does. And make sure that you say things like what the circuit is, and It's probably enough. But in other words, you have to rewrite in your own words essentially the problem statement that I gave you, saying what this function does. And then you're going to say what your name is, percent by input variables list each of v comma r1 comma r2 here with a clear definition of what it is. If you did a good job in the function description, you can say the resistance of resistor R sub 2. You might want to put R1, for instance, equals resistance of resistor R sub 1, so that it's not the one thing is resistance and the other talks about what resistor it is. That would be a good way to say it, R sub 1, in which case you probably have R sub 1 up here in your description. But you got more to it than that. And then percent output variables this function. So it should probably be indented there for readability. Function returns nothing. And percent, and then attribution. I don't know, I think, write, tell me a story. I think I'm going to say, I wasn't sure linspace worked, but rather than look it up, I experimented with it at the command level. I call it the MATLAB command level. That's here. That's the MATLAB command level. And, I'm assuming it's pretty far up there. There it is. I was playing with linspace right there, and that worked. This was when I was testing it, and then this mess. This is like a whole ton of values. Calling it like 101 columns. That came because I forgot to put the semicolon on there, but I'm putting it on there now. And notice I type in plot, hit return, it produces a graph, but it doesn't print anything to the screen here like it did when I had that semicolon off. Alright. So, trying to fly by the seat of my pants here. No checklist, but I got function description, name, input, output. I'm supposed to have explanation of code that is not straightforward. This, I'm setting up the array of R23 values. Up top it was clear that I was plotting something versus R3, so it's clear I gotta have an array. Here I'm going through the calculations that one would know if one looked at my paper. I guess in some sense you would have to work it out or look at a pencil and paper solution to know what's going on for sure. But I think the symbols are pretty clear, so anybody that knows a little bit of physics in this area can figure out what's going on. And then the plot command. So I don't really think this is self-documenting. I picked variables that are pretty consistent with what you would expect them to be. R23 is clearly the resistance of the effective combination resistor R2 and R3. You can see that they're in parallel. Plus it says it'll say so, or you should say so at least in the description of the function. And so I don't think we need any code explaining what we're doing on a step-by-step basis. I didn't do anything fancy is really the idea. And then got the graph all doctored up, got the attribution. So I've gone through a mental checklist in my mind. I'd say we got everything covered. Just make sure I haven't changed anything. I'll save it one more time, and then run it maybe a couple more times. Take a look at the graph there. Actually, I didn't close the graph down, so I'll try that. Make sure that it's working if I close the graph down. And what do we got? Graph that I had R3 values. Here they're going up to 8,000. Let's check that because I played around with that. See what they should be going up to. They should be going up to 10 times this, which would be 7,500, which is pretty darn close to 8,000. And in fact, that looks like that's where this really does end. Alright, so I think that's good. Should go to 6 volts because I got these two are equal. So we get half the voltage dropped across there in the limit as R3 goes to infinity. For R2 is the same thing as R1, which is what I picked. So I submit. Make sure nothing extra is printed to the screen. Yeah, that's a wrap for Project 2 video number 3.